so what we're going to do is we're going to finish up the last lecture. We're going to do ellipse and hyperbola, and then we'll do the test for the circles and the parabolas. Now, as far as your final exam is concerned, that is next Monday. Your final exam will be next Monday. For that final exam, you will need a Scantron, a pencil, and a calculator. Those are the three things that you will need: a Scantron, a pencil, and a calculator. You will not need an index card, but you can use your comments packet that you have in front of you. I don't think that you're going to need it, but you can use that. But you cannot use an index card. So, you need a pencil, a calculator, and a Scantron. If you come without a Scantron, you're not going to be able to take the final exam until you get a Scantron. So make sure you have a Scantron in the class. Okay? The final exam is multiple choice. So use, to bring your common sense brain, and use the answers that are most reasonable, I guess you could say. Just to tell you, the one-choice final exam is the easiest of all the final exams. So, if you study, the study guide review that's already on Blackboard, you shouldn't have any problems at all. Again, on Blackboard, the review is there. It has everything worked out. Anytime between now and next Monday, you need me to answer any questions or go over any other problems on the review. Email me, come in, see me, whatever you need to do. I'll be more than happy to go over any of those problems on the review that you need to. Now, I'm not going to work the review for you because I've already done that. It's on Blackboard. But if you sit down and you're like, I have no idea how to do this, I'll be more than happy to do that. Sometimes it's okay? So, we're going to talk briefly about the ellipse and hyperbolas. And the reason why I say briefly is because it's touched on very briefly on final exam. In fact, when we go into calculus, the only comments that we use in Cal 1 is the circle and the parabola. The hyperbola and the ellipse are not touched on again until you get into Cal 3. And we'll talk about it explicitly when we get to Cal 3. Okay, so an ellipse, basically what you have, you know how parabola works, right? So basically what you have is you have two of these parabolas that are turned to each other, and they intersect. So that's basically what's going on with an ellipse. So now instead of having one foci, we have two foci. And the foci, of course, are going to be on the inside of the ellipse. So here are your foci, which means that your vertices are going to be behind these foci. And in an ellipse, we have two axes. You have your major axis, which is going to be your long axis, and you have your minor axis, which is going to be your short axis. So an ellipse is a set of all points in a plane such that the sum of the distance for two fixed points called your foci is a fixed constant. Alright, so here are all your formulas. They're on your formulas page, whatever. Now, on the final exam, it's going to ask you to name, it's going to give you an equation, and it's going to say name the conics, and that's going to have listed the conics that are for you. Now, we already talked about how to look to see if you have a circle or a parabola, right? You know that you're looking at a circle, and I forgot to mention one thing, so I'm going to mention it here. You know you're looking at a circle if you have two squared terms, and your coefficients are the same. And there has to be a plus sign in between those two square terms. And the minus sign is going to be that hyperbola. So make sure you have that plus sign in your formula. You know how on your formula, if you look in your formula page in the circle, you have that plus sign in between there. It's x minus h quantity squared plus y minus a quantity squared. That plus sign's got to be there in your equation. Okay, it's a minus. Be careful of that. And then if you have one squared term, we know it's going to be a parabola. And depending on which way this thing goes, depends on if your x is squared or y. Okay? So now, when we're looking at an ellipse, we have squared terms. We have two squared terms. Your coefficient of your x and y squared terms are not the same. If they are the same, you're looking at a circle on the ellipse. Okay? You gotta have something longer than tall or taller than wide. Okay? It cannot be the same as a circle. Okay. Remember when we talked about at the very beginning of phonics last week, I told you X and H always go together. Well, now what we're going to do is we're going to throw another variable in there, and that's going to be A. These always go together. X, H, and A always go together. Y, K, and B always go together. They're not going to be separated at all. So, how do I know that I'm looking at a longer than tall? That means that it's going kind of like a football, it's going around. Okay? Longer than tall. Your A squared term, your term underneath your X and H is going to be bigger than your B squared. That's how you know it's going to be longer than tall. Your X direction is longer than your Y direction. Do you understand that? A goes with X. X is this direction and Y is this direction. So your X direction, your A, is going to be longer, bigger than your Y direction, your B. Okay? That's how you know you're looking at longer and tall. Alright, so as always, center is going to be your HK, and notice you do have the minus signs in here again, so it's the opposite of H and the opposite of K, opposite of what you see. Once you have the center, you have choices again. You know what I'm doing. You can use your formulas page if you want to. Those formulas are right here. Okay? So if you want to use those formulas, you can. Your major axis, however, is going to be 2 times A. Not A squared, just A. Okay, it's going to be 2 times A. Your major axis is equal to 2 times A. Now, what is that? The endpoints of your major axis, your long axis, the endpoints of your major axis is going to be your vertices. We know what vertices are, right? So, the endpoint of your major axis is going to be your vertices. Well, the minor axis, the short axis, is going to be 2B. And so, the endpoint of that minor axis is going to, that's what you're going to call it, is endpoints of the minor axis. And again, there's the formula. And then the focus is what it's going to worry about. Okay. So, again, on the test, what's going to happen is you're going to be given an equation. And it looks like this. Okay? And in this equation, it's going to ask you, what is this point? Well, you have 2 squared terms, so you have possibilities. You know it's not parabola, so just throw that one out. But I see the plus sign here, so it's either an ellipse or a circle. And I see the coefficients are different, which makes it an ellipse. You understand the process of elimination? And that's what you're going to do on the final. Okay? There's 2 questions on there that like that. Okay. Going back to the formula, notice it's got to be set equal to 1. This formula right here is called standard form. This is workable form. We talked about that last week. Standard form. You've got to have your fractions set equal to 1. Okay? So, this is in standard form. This one is in standard form. So, remember I told you last week that there's no parentheses, your vertex is what? Okay, so you're not sure what your center in this case is going to be 0, 0. Okay, so A squared is equal to 25, and B squared is equal to 9. So what is A? And what is B? Alright, this is all I need to know in order to graph this. Because on the test, I would say, where's the center? Your center is HK. And I would ask you, what are the vertices? Well, if my center is 0, 0, and the endpoint of my major axis is going to be 2 times my bigger number, which is 5. So I know add 5 to the right. And those are my vertices. So my vertices are going to be negative 5, 0, and 5, 0. The endpoints of your major axis are going to be your vertices. Find that, look at it. You go that many units to the left and that many units to the right off of your center. Okay? So what do you think about your minor axis? Your endpoints of your minor axis. That goes off the B. So off your center, you're going to go 3 up, 3 down. So we're going to have 0, 3, and 0, negative 3. And that's all you need in order to draw an ellipse. So if your equation is in standard form, it's fairly simple. If it's already in standard form, how do I know it's in standard form? You have your fractions that equal. Got to be set equal. Once you have it in standard form, pick out your H, pick out your K, find A, find B. That'll give you your vertices. So let's look at this one. Is this in standard form? No. What do I need to do? Divide by 180. Divide everything by 180. It's an equation, so what I do to one thing, I have to do to all of them. So we're going to divide everything by 180. So now I'm going to get 5 will go into 180 how many times? So you're going to have x squared over 36. 36 will go into 180 how many times? And then 180 divided by 180, of course, is 1. Now it's in standard form. So what is the center? No parentheses means 0, 0. No parentheses means it's going to be 0, 0. Alright, so I need the vertices. To do that, I need to know what A is. A squared is what? 36. So A is what? 6. So I'm going to go 6 to the left and 6 to the right. So my vertices are going to be negative 6, 0, and 6, 0. Endpoints of the minor axis. I need to know what B is. B squared is 5, so what is B? Square root of 5, which is some decimal. What is it? 2 point? Yeah, we'll say 2.2. So we'll go 2.2 up and 2.2 down. So we'll have 0, 2.2, and 0, negative 2.2. Alright, so this one, we're not on the origin anymore, right? What is the center? Very good. Negative 3, 2. Take the opposite. Here's your H, here's your K. Alright, so what is A? And what is B? So we're going to go negative 3, 2. There's my center. So to find my vertices, what am I going to go? And what am I going to do? You're going to go to the left 4. And that's going to be negative 7, 2. And I'm going to go to the right 4. And that's going to be 1, 2. Endpoints of the minor axis, what am I going to do? Up 2 and down 2. So we're going to have negative 3, 4, and negative 3, 2. Question? Okay. Now, I want you to coefficients of your squared terms are not the same, and you have the plus sign between them. Okay? Minus sign means that you have a hyperbola. Okay. In order to graph this, in order to discuss and graph the following ellipse, we're going to have to get this in standard form. So, what we're going to do is we're going to group all of our x's, put that plus sign in there, and group all of our y's, and move everything else to the other side. Okay? To complete the square, your leading coefficient must be 1. So for my x grouping, that's fine, right? For my x grouping, how am I going to complete the square? What number is going to go there? Half of 6 is 3, and 3 squared is going to be 9. So I know I'm going to add 9 over here as well. Now, for the y grouping, I've got to factor a 9 out. Do you understand why? Your leading coefficient has to be 1. So I'm going to factor a 9 out, and that's going to give me y squared minus 4y. And then complete the square, what am I going to get? Half of 4 is 2. 2 squared is going to be 4. But, time out. We're not adding 4 to the right-hand side. What are we adding? Yes, 4 times 9. We're not adding just 4. We're adding 4 times 9, so we're adding 36. So be careful with that. You knew it was going to get harder than that. Alright, so finish it up. We're going to have x plus what here? X plus 3 quantity squared plus 9 times y minus 2 quantity squared is equal to 9. Is this in standard form? Why? It's got to be set equal to 1, so we're going to divide everything by 9. So we're going to have x plus 3 quantity squared over 9 plus, what happens to these 9s here? They cancel out, but we still need a b, so we still need that 1 down there. You guys know what b is, everyone? Is equal to 1. Alright, so now, what is the center? Negative 3, 2. Good. What is A? And what is B? Alright, so off the center we have negative 3, 2. Not up 3. A is bigger, which means we're going in the x direction. A is always in the x direction. A goes with H, goes with X. A, H, and X go together. So in the x direction, we're going to go 3 left and 3 right. B, however, goes with K and Y. So that's the up and down direction. So we're going to go 1 up and 1 down. Just remember, if A is bigger than B, it's longer than both. Alright, completing the square, you're going to have that on your test tomorrow. So everybody clear on how to complete the square, where all those numbers come from? Alright, so taller than long. Look at this. B, everything's the same. It's just B is going to be bigger than A. So if you're looking at an ellipse, and you know it's an ellipse, I know it's an ellipse, this is an ellipse standard form, I know it's an ellipse, B Alright, so this one, what's your center going to be? Center's going to be 0, 0. What is A? And what is B? Alright, so this time, in the X direction, what am I going to do? 2 to the left and 2 to the right. In the Y direction, I'm going to go 4 up and 4 down. See what happens. Now it's longer than 4. So which ones are my vertices? Vertices are off the major axis, so it's going to be 0, 4, and 0, -4. Good. And the endpoints of the minor axis are going to be the other ones. So you have -2, 0, and 0. Good job. Good morning. What do we need to do? Divide everything by 16. That's right. So that means we're looking at any of those. Always. Alright, so we're going to have x squared over what? A going to itself one time, A going to itself 2 times. And then y squared has nothing that's going to cancel out. So your center is going to be what? A is what? Square root of 2, which is what? Give me a guess. Square root of 2 is like 1.1, is that right? 1.4. And then B is going to be what? 4. So you got 0, 0. In the A direction, which is the X direction, we're going to go 1.4 to the left and 1.4 to the right. And then B is 4, so we're going to go 4 up and 4 in. So your vertices are going to be what? And the endpoints of the minor axis. So do you have the gist of the ellipse? Okay. So, can you do one off the center? Try it. Try doing this off the center. Alright, I'm going to catch up to you. So the center for this one's going to be 4, -2. You get that? Good. A is 2, and B is 5. Yes. We'll go 4, -2. In the A direction, the X direction, I'm going to go 2 to the left and 2 to the right. And in the Y direction, I'm going to go 5 up and 5 down. So my vertices are going to be the endpoints of the long axis, that major axis. So that's going to be 4, 3, and 4, -7. And then the endpoints of the minor axis are going to be 2, -2, and 6, -2. Alright, so again, would you be able to look at this and tell me if this is an ellipse? There's something in there that may be a little bit tricky if they make you think that it's a hyperbola. That minus sign. Remember I told you, if I rewrote this in descending order, that plus sign would go with the 4y squared, right? So that plus sign would be in between these. So this is actually an ellipse. Okay. If this was a hyperbola, that negative sign would be like this. Okay. Alright, I'm going to run through this because you're going to have to be completing this question. We've already done it, so. We're going to revert our x's together. Put that plus in there, and we're going to group our y's together. And then we're going to move that 16 over and make it negative. Change the sign. Okay, before you can put the square, your leading coefficient must be 1. Okay? Tonight, when you're doing your circles and your graphs, well, when you're doing your circles, make sure you have that problem. Okay? So, you should not have figures on it. Alright? But, for these, we're going to have to take a 9 out, so we're going to have x squared minus 4x. Complete the square, and you're going to get 4, right? Out of 42, 2 squared is 4. So I know that I'm going to have to add 4 here. Now here I'm going to take a 4 out, and I'm going to have y squared plus 4y, and that's going to be 4 again. Oh. Yep. See, that went up. First one, 4 times 9 is going to be a 36. The second one, 4 times 4 is going to be 16. There we go. Don't forget that, like I just said. You didn't just add a 4 here, you added 4 times 9, which is 36. You didn't just add a 4 here, you did 4 times 4, which is 16. Alright, so, factor it down. This is going to factor into x minus 2 quantity squared plus 4 times y plus squared is equal to 36. Now we're going to divide everything by 36. Alright, so 9 will go into itself 1 time, 9 will go into 36 4 times, so we'll have x minus 2 quantity squared over 4 plus 4 will go into itself 1 time, 4 will go into 36 9, so you'll have y plus 2 quantity squared over 9 is equal to 1. Okay. Now from here you should be able to do this. Graph this. Find the center and the major axis and the minor axis. Split those ordered pairs. What's the center going to be? Good. What is A? And what is B? Good job. So your center, you're going to go to the right 2 and down 2. So there's your center. How many units am I going to have to go left? 2. How many units am I going to have to go right? How many units am I going to go up? And how many units am I going to go down? Good job. So which of these 4 points is my vertices? Up and down, the longer ones. Good. So it's going to be what? 2, 1 and 2, negative 5. Good. And then the other ones, of course, are going to be one's the minor axis, so we'll have 0, negative 2, and 4, negative 2. Good job. Alright, that's the ellipse. Any questions? So now what we're going to do is we're going to take all of that and invert it. Alright, so this is the hyperbola. Basically what you've done is we had that parabola that we did earlier. We did 2 of them and put them together. Now what we're going to do is we're going to take the parabola and go away from each other. Okay. So, you have the 2 parabolas going away from each other, which is your hyperbola. A hyperbola is a set of all points in a plane such that the difference in distance from 2 fixed points called Vertices are going to be endpoints of the transverse axis. Again, it depends on whether you have the A or the B. It's split. Endpoints of the conjugate axis is the perpendicular to the transverse. That's just a little bit another way of saying it. That's all it is. And then your foci, the two fixed points inside the hyperbolas. We're not really going to worry about those, and we're certainly not going to worry about the asymptotes. Okay. So how do we do this? Branches opening right and left. Branches opening right and left. How do you know? It's just like on your parabola, you gotta know that those things have to be on left or right. Same thing with the hyperbola, you gotta know that those opening right, left, right, down. Well, notice you have this minus sign here, okay? And right here it says your A squared is under your plus, your positive grouping. Well, what I like to say is if that X, H, and A, because that's not okay, X, H, and A come first, then you're opening right and left. Watch this. Y, K, and B come first. That means you're going up and down. Okay? So, that's what I like to say. So if the X grouping comes first, then we're opening right and left. Your center's still going to be HK. Your center's still going to be HK. The only thing is, be careful with this, like I was telling you last week, and tonight on your parabolas, you have to be careful with this too. When your Y grouping comes first, don't make the mistake of saying this is H and this is K. H still goes to X. K still goes to Y. So don't get that backwards. Alright, so your vertices is going to be 2A again. And your endpoints of your conjugate axis is going to be 2B again. Like both sides, we're just not going to worry about. Okay, so if I gave you an equation that looked like this, and I said name the function, things you got to look at. Number one, I have two squared terms. So it could possibly be a circle, a hyperbola, or an ellipse. Number two, the squared terms do not have the same coefficient. So automatically, circle's gone. So now we're going to add ellipse or hyperbola. Because this term is negative, because one of my squared terms is negative. Because one of my squared terms is negative, I have a hyperbola. Okay? And that's what you're going to have to do on the problem. Alright, and I think the equations on the following now are going to be in general for themselves. Okay, so let's look at this. My center, this is standard form because it's set equal to 1. Again, in standard form for hyperbola, it's still equal to 1. The center is going to be 3, 4. A is what? B is what? Okay. Since my X grouping comes first, which way does this open? Up, down, left, or right? If your X grouping comes first, it's going to open left or right. It's going to open about the next one. If your X grouping comes first, it's going to open about the next one. So that's left and right. Alright, so if I graph 3, 4, my A, that's where I'm going to go. I'm going to go 5 to the left and 5 to the right. These are my vertices. So my vertices are going to be -2, 4, and 8, 4. So for my conjugate axis, I'm going to go up 6 and down 6. And you might want to label those vertices just so you know which direction your hyperbola is going. So your conjugate axis, or it's not really your minor axis because that axis is conjugate axis is going to be 310. And 3 -2. Now, to graph this thing, this is what's fun. To graph this thing, what you need is you need a square. Going through those 4 external points. And then once you have your square, what you need is diagonals going through this one. These diagonals are called asymptotes. Now, do you remember the definition of an asymptote in chapter 5? So if your function, your graph, cannot go across the asymptote. Well, if I know that my hyperbola have to go through the vertices, look at this. Right here is one of the vertices, right? Well, if my graph starts here and it can't cross the asymptote, then it's going to bend when it gets closer to the asymptote, right? By definition of an asymptote. And then the other one is going to go this way. And there's your hyperbola. So, what are you going to do? You're going to find your center, you're going to find your HK, and then you're going to find your vertices and your conjugate axis. That's just your A and your B. Just remember, A goes in the X direction, B goes in the Y direction. Draw your box, draw your diagonal, draw your hyperbola. So let's try again. What's wrong with this? Yeah, we got to get it set equal to 1, right? So we're going to divide by 18. So we're going to get x squared over 9 minus y squared over 6 is equal to 1. X grouping comes first, so I know that I'm opening left and right along the x-axis. My center is where? Good. No parentheses, 0, 0. A is what? And B is some decimal. What's the square root of 6? What? Alright, so we're going to go 0, 0. And we're going to go 3 left. And these are actually going to be my vertices because my x grouping came first. 2.4 up, 2.4 down. And now we need our box and our diagonals. And here's your hyperbolas. Again, once you put your vertices on your graph, label them. Make sure you label them, because if not, you're not going to know which way this thing is going. Up, down, whatever. You're going to get totally confused about it. Okay. So, this is what I want to do.